Hello, good afternoon everyone. Today the third class we are going to discussing the powder metallurgy. I hope first and second classes maximum students are attending. Those who are not attending, I have already have sent a short copy of whatever the slides I'm going to preparing that I sent to the WhatsApp group. Please go through that. If you not understand, please contact me and call me, or you can text me on WhatsApp also, no problem. Once again, very good afternoon to everyone. My voice is, I hope my voice is audible to everyone. Okay, fine. What about slide is clearly appear to everyone? You can able to see the image, and what the texts are going to be prepared slide is you can able to see. Okay, okay, okay. So very important topic. Okay, this is a third class of photometallurgy. Already we are in the post step. We are discussing the second class photometallurgy. The first step is photoforming. All the 5 different methods we are discussed with the diagram, and few videos also I have shown to the students. Okay, and remaining 3 steps today we need to discuss. Very simple concept is there, not much difficult, but thing is that we have to understand how much importance all the steps are there, and role of the each and every steps is having a own role is having. See that. Second one is blending or mixing. It's a very important mixing or blending. Okay, blending means it's not a different word, it's a similar word to the mixing only. Or is there means you can use blending, or you can use that also, mixing also. Blending means it is a one substance is it is going to mix to the different things, it's going to be called as a mixing. Blending is a coarser fraction with a finer fraction, ensures that the interstices between large particles will be filled over. Powders of different metals and other materials may be mixed in order to impart special physical and chemical properties through the metallic alloy. We know that mixing is also very important part of the casting, foundry, as well as the powder metallurgy. The concept is very simple, but role is very important. Okay, so means whatever the special physical and mechanical properties through the metallic alloys, we are going to be a number of devices are there. We are going to be with through that devices we are going to doing the mixing of the whatever the powders we go to, metal powders we go to, that we will do that. Still, lubricants may be used mixed to improve the powder flow characteristics. Not only use the powder only, we are using the lubricants may be mixed to improve the powder flow characteristics, because if you not use the lubricants generally we are using for the two function. The thing is that first one is it reduce the friction. Okay, it is avoiding the friction between the two atoms. Okay, then it is going to be accumulate between the two atoms particles, means not atom, powder particles. Okay, it is lubricant means it is going to be help to improve what it going to be help to improve the green strength. Binders such as wax or thermoplastic polymers are added to improve the green strength. Okay, so main thing is of the mixing is that we have to how we going to mix, what are things additives or can lubricants we going to use and increase the green strength and reduce the friction, and you have to mix in the very well, that should be help to the more dense product we are going to be producing. So mixing very important and very simple, means if you see go through the slides you can say that I think it's a very simple, but you have to remember the points. 3 points I can say in the slide is there. 3 points you have to remember. Powders of different metals and other metals may be mixed in order to impart special physical and mechanical properties through the metallic alloy. This is a very important point. And second point is lubricants may be mixed to improve the powder's flow characteristics, because if you not use the lubricants, the whatever the powder metal powder you are going to use, no, it is not that much flow, means it's going to be attached to the one part to the other part. It may be sometimes you'll use for the screw blade, whatever the blades and all. Okay, it's going to be attached over there. If you use the lubricants, it's going to freely start movable, and it's mixed with very nicely. Okay, it's good for the producing the component. And so the last one is binders such as wax. So we are using the wax or thermoplastic polymers added, means these we are going to use to add, intentionally we are going to adding the wax and thermoplastic polymers for the, we need to increase and improve the green strength improve purpose we have to using these things. So I hope you understand this whatever the explanations. Okay, so I'll show the diagrams, you will understand better. Shall I go for next topic? Okay, yes. See here, very important diagrams are there. Blending and mixing are accomplished by mechanical means. Mechanical means, in the previous slide we have discussed physical and mechanical. Okay, so here we are going to be see the diagram. You can image, you can able to see here. Both are there. First one is rotating drum is there, and second one is rotating double cone is there, and third one is screw mixture is there, and fourth one is blade mixture is there. Okay, I hope everyone seen that it's a means road construction time and building construction time and apartment construction time. Have you seen that four-wheeler, I mean six-wheel vehicle is there, that will be having a drum. That drum is always rotating. Inside the drum, have you seen anybody? Inside the drum we are going to fix the rotating blade, means fixed blades are there. When the drum is being, the blades are directly attached to the drum. When the drum is started rotating, even blades are start rotating. Inside the mixing, whatever the means, for example concrete, for the concrete, whatever the stone powder as well as mixed with the some percentage of water, it going to be continuously rotating. After that it is both the substance should be mixed in the very nicely mixed. It going to form the in the form of cement. Okay, the first one is rotating drum. So rotating means it start rotating continuously. So, okay, it start rotating continuously, and is continuous rotating in the sense is going to be happen in the mixing. Okay, and second one is double rotating double, means in the two axis it's going to be moving in the like this, and this also it going to be rotating. And screw, you know that best example for that, even the footpath, many of them are having juice, I think orange juice and the pineapple juice. They will be just small four-wheeler vehicle will kept in a machine, that is juice machine, you can call it as that kind of, which that is having a screw mixture type of the mixture is there. Then it's going to be start rotating, then juice is going to form, and they will give the juice to it. Next one is blade mixture. Blade mixture means, you know that then vertical cylinder is there. It's having both the side, it's a blade is going to fix. If this axis is start rotating, whatever the spindle is start rotating, the blades start rotating. Whatever the components or substances we going to use for the additives and as well as the lubricants, it's going to be mixed in the very fine. Then it's going to be finally form the whatever the means it's going to be finally form the it increase. Whatever the all the four diagrams what is going to explaining, this is for the increase in the green strength of the powder metal. What you going to use the metal now, that is having a, if you want to improve it, it's going to be improved, and it's forming the green strength of the material. It's going to be increasing. Okay, so for the flow of means flow purpose of the powder, we are going to use the lubricants. Lubricant is going to be reduce the friction of the particles. Yes or no? So I hope you understand. Very simple concept is there. I hope understand everyone. Is it understanding? Okay. Okay. Means what? Screw. Okay. Means it is having a spiral. The spirals it is in the way of spiral it is having, and it is the one in the between the spiral rotating the screw. It's having a one cylinder. It's going to be attached to that in like a staircase. Then it's going to be start rotating. What will happen? It's going to be inside. Then it's going to form the mix in the well manner. Shall I go for next topic? Okay, this is the third one, a very important topic. I think in the powder metallurgy, out of four, third is very important. Compacting. Compacting maybe have you used in the, we can call it as a pressing also. This process already we are did in the fourth semester foundry lab. Foundry lab already in the many of the different I think mold we are going to preparing. Mold is having different shape of mold is there. Then we are going to prepare a green sand in that foundry lab. That will mix it in the very well and pour into that. Then take the hammer and hit that whatever the sand is going to be filled then again cope and drag in. We are going to use, and we did that practically in the foundry lab. I think it's not difficult to understand, okay, because we did compaction as well as mixing, powder forming, everything we did in a foundry lab. It's a very simple concept. I think everyone, I hope everyone has to understand this, okay. Just I'll read the what I'm going to preparing the slide for the very simple and simplest way to understand. Not much difficult words. I'm not using sentence. Also very simple sentence are formed for the understanding purpose. Once you understand in the exam, if maybe they ask any questions from the model, I can say that this is a not fixed, this is a fixed question, this is not fixed. I can't say that, but you people understand the concept, you will, if they may ask anything, you will be able to write, okay. Once you understand the concept, once concept is clear, definitely write. A very important thing is that in the powder metallurgy or in the additive manufacturing, the diagram should be very neat, parts labeling should be very neat, and at least you have to working principle right neatly, then definitely you get a good marks. By the extra things you have to know about advantage, disadvantage applications, definitely get a good marks. Let's come to the point. Compaction, exert force on force on something so that it become a more dense. Exert force means apply the force on something so that it becomes more dense. If you example, in the foundry lab we are going to be hitting, continuously hitting the ramp, okay. So 3 to 4 times we will put to the green sand, yes sir. If you instead of hitting, just you put the sand, and after that you can remove the cope and drag, you will not get 100% shape of the whatever the what you want to do, no, that shape you will not get. That also because density is not there, because strong dense product is not there, no, then how we go to cut? Also cutting also very impossible. Cutting also not possible. You're going to fix, you're going to cut in the sand, hexagonal, pentagonal, yes or no, a sprue and something you're going to use in the pins, and something you're going to use, so if it is when compaction will be happen, then only it is possible everything. If it is compaction is not there, then nothing can do, yes or no. If the compaction is there, not there, then we can't able to produce the product also, no. Compaction rate role is very important. Exert force on so that it becomes a more dense. A compaction applications of high pressure to the powder to form them into the required shape, okay. Compaction application means what? It's going to apply a high pressure to the powder to form the into the required. See, if it is compaction process is not there, you can't able to achieve your shape and size, and your rings, whatever the strength of the metal is not able to find, not able to get. So compaction is very important. That is on the second point is very important. Compaction application of high pressure to the powder to form them into the required shape. The conventional compaction, third point, the conventional compaction method is pressing. Means compaction method is pressing, in which opposing punches squeeze the powders contained in the die. What will happen here? I think it is a common process to all the like this kind of processes. We are having two punches, one is lower punch and another one is upper punch, and we are having a die also, okay. Before fixing the die, we are going to fix the first, we will keep the lower punch above that lower punch, we are going to keep the die also. Inside the die we are going to pour into the whatever the sand or molten metal we are going to force it, but in the polymetric comes we are going to pouring the metal powder. So after that again we are having a upper punch, okay. Upper punch is there, just you have to press with the upper punch. What will happen? The anyhow bottom lower punch as well the dies are going to fix it. If you apply the pressure, if you apply the compaction on the force, you are going to apply to the upper punch, it's going to be hit and it compacts, and it is going to be from the more ends. For your more understanding purpose, I will show the image. I think you clearly understand. You can able to see the slide over here. Diagram of compaction is there. So I think very simple is there, and you can understand very easily also. Three diagrams are there. The first one is even I said before 1 minute back only. Die is there. You can able to see here, and lines can show that, and the lower punch is there, and upper punch arrow mark gap is there between the lower and upper. Green color can able to see, that is a metal powder, okay. That is the first step. Means we are going to be just we are going to put it the sand or metal powder, and just we are going to keep on the upper punch on the metal powder. Second, you can just have to see here, just we are going to pressing, means compaction is happening, just we are going to apply the force. Okay, now what will happen, the between in the first diagram gap is there, but in the second diagram there is no gap, because it is going to be attaching the directly going to pressing lower punch to the upper punch, between it is having a between the lower and upper we are having a metal powder. After that, in the third diagram you can able to see the arrow mark will be above is there, because gap will be there, means after the punching whatever the green, whatever the dense product we are getting, that is will be there in the compaction, that's shown in the green color. You can able to see. I hope you understand. Very simple and very, I think what you call it as very simple and very easiest concept it is, not difficult also. We don't want to worry about much concept about the compaction also. Okay, so we will go for directly to the next topic is sintering. It's a very interesting and very important also, sintering. Okay, many of them are not understanding. Sintering means it's going to be a deposition, means it's going to be a itself it's going to be converted into a atoms or particles, or the powder particles are going to be attached to one over the other. Just I'll read. Sintering or pretase is the process of compacting and forming a solid mass of material by heat or pressure without melting it into the point of liquefaction. Sintering happens naturally in minerals deposits or as manufacturing process used with metals, ceramics, plastics and other materials. Please, one thing you have to remember it. Sintering happens naturally in minerals deposits or a manufacturing process used with metals, ceramics, plastics and other materials. Sintering in the first model, I think in the basic model, first model we have discussed the selective laser sintering. Okay, in that process I clearly explained what is the meaning of sintering and how it is going to become metal powder, or for example ABS, acrylo nitrile butyl styrene, how it is going to be sintering, or instead of that a nylon, okay, or polymer, some other plastic materials also, how it is going to be sintering. I shown everything with the diagram. Okay, still that's same concept. Okay, same concept will be the sintering. It's the last step of the powder metallurgy. First step is powder forming, second is mixing, third one is compaction, and fourth one is sintering. Okay, sintering means we are going to apply, means after the whatever the compaction, heat or pressure without melting it to the point of liquefaction. We are going to be sintering, means it is not without melting. Okay, before melting point, whatever the deposition means, it's going to be converted into solid, whatever I guess. So once we go past the whatever the heat, it's going to become a solid. Means that how much heat you will have to give before the melting, means without melting, that should, that whatever the metal powder material you are going to use now, that should not melt. Okay, that point you have to achieve it, then only you will get the proper sintering. That is we call it the finally finished product. Okay, I hope you understand the theory part of the sintering. I think slide is very clear to understand. I think a very simple concept is it. Shall I go for the next topic? I will show that diagram of the sintering. Diagrams of sintering. I have in the slide two diagrams are there. One is solid state sintering and liquid phase or liquid state sintering. It's normally happen both the things in the sintering process. Solid state sintering means just you have to see the left video, left image, not video, left image. In that atoms, or you can call it as a powder particles, are free are there. They are freely suspended, means there is no contact each other. After the arrow mark, you can able to see that's going to be a circle become some hexagonal shape. Okay, initially it was having a oval shape. After that is having a hexagon, means it indicates solid state sintering. Means solid particles, how they going to be sintering, how they going to be depositing. Okay, that is it indicates. Okay, See, just there is no gap between one particle to other particle, but above the arrow mark you can able to see maximum all the particles having a gap. Okay, there is no contact to each other. But here after the centering, after the arrow mark you can able to see, below the arrow mark you can able to see that is all the particles are attached one over the other. There is no gap between the one particle to other particle. It's look like a hexagonal one. It is attaching one face to other faces. The particles are going to be attaching. This is a way of sintering you call as a solid state sintering. And next I would like to explain the one more thing is important one is liquid phase sintering. Liquid phase sintering, this is a in the slide, right images that you have to concentrate. Okay, I hope you clear. Clear visual is there, image is visible. Okay, 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 okay. So you can able to see here in the same how the in the solid state sintering is there, like that similar also in the liquid. Even the before sintering the particles are free suspended, means free are there, there is no contact between the one particle to other particle. But after the sintering, going to be attaching one particle to other particle, means there is a link will be there, means I can't say the it is not similar to exact similar to the solid because it is liquid property. Okay, liquid it's means one it, but thing is that particles are whatever that we are going to use, for example molar material having a liquid phase, but thing is that its atoms are particles are going to be attaching. Okay, this the concept is that sintering. Okay, it may be a solid, it may be a liquid. Thing is that deposition, how is the atoms or particles are going to be attached one over the other, means it is finally sintering. So sintering should be a before melting. Okay, if it is start melting, then we are not considered as a sintering. Yes, sir. So should be this case should be a before whatever the heat and what you are applying that things, it should be a before the limiting, before the melting point of that point will be there, no? For that particular liquid, for that particular state solid, you have to use that. Then before melting point you have to sintering it. Then finally what type of what shape of compact or object you are able to get, that type of will be able to get in the sintering process. Okay, I hope these are the three whatever the left out, means what we are going to yesterday discuss the powder forming metallurgy. It's having a 5 different methods. Okay, first one is we are going to be discussing atomization. Second one is you can able to call as a electrolytic deposition, chemical reduction, condensation, crushing and milling, with a diagram, with a video, with a slide explanation we are going to be did in the previous class. Whatever the remaining part, okay, that topics we are going to discussing today. Okay, so today we are discuss the three concepts. The first thing is compaction means what, how you are going to do the compaction, and third one is we are going to do the sintering, and one more thing we are going to discuss before this topic is a blending or mixing, how we are going to mix it. Okay, how we are going to mix the whatever the powder metal. Okay, that is very important concept. What are the equipments we are going to use. Okay, in generally what are the things we are going to use and how we are going to do the mixing and all, everything we are going to study it in the today's topic. Okay, and hello, okay, anything else, any queries? No. Okay, means in the maybe in the exam point of view they may ask anything, compaction, maybe blending, all these things, but according to me you should be concentrating on the powder forming is very important, as well as the compaction is important, and sintering is also important, because mixing is a very simple concept, everyone can write easily and draw the diagrams also very easily. Okay, I'm not too much worry about that. Remaining parts you have to understand. Then before these classes we are discussing the introduction part of the powder metallurgy. What is the definition of the powder metallurgy, what is the role of that, yes or no? Then what is the history of that, what is the application of that, what is the advantage of powder metallurgy, what is disadvantage of powder metallurgy, all the topics related to powder metallurgy introduction class we are discussed very nicely. Okay, I think many of them are attending the classes. Okay, please try to attend the classes regularly, then you will understand the topic of each and every one. Okay, it's not a big task to understand, because online classes means it is a many of them are facing problem for the network and can't able to hear the voice and all. Okay, it is 1 or 2 days problem, you have to continuously try it. Okay, means definitely you get a thing proper range, and so if you just log in, join it, then you understanding. So whatever I'm going to prepare in the notes, by it may be a handwritten notes, it may be a slide, it may be a video, it may be a soft copy of that, whatever things I have material, no, I will send to the everyone. Don't worry about that. The thing is that you have to understand the concept. If you not understand, please contact me. Thanks for the attending. Okay, have a nice day. Have a nice day. If you not anybody, please request anybody not understand, please reply me. Okay, don't after the completing the class, you don't ignore that. Just you have to go through the topics. I will send the notes. Please go through when you are going to free. Okay, okay, thanks for the attending. Okay, hello. Okay, thanks for the attending. Okay, bye bye.